Good evening. My name is Miguel Santana, and with my partner Nicolas Rovira, we'll be presenting our logistics final project. The objectives for this presentation is to develop a warehouse layout. The way we'll develop this warehouse layout is determining cost of racks, equipment, office, and materials inventory. In this presentation, we'll also do a follow-up step by step of all the process we did to get to this warehouse layout. For this project, we were provided an initial data. Initial data is an ABC criteria that presents the rotations per classification and how many items belong within this classification. We're also provided with the four main products produced by the materials X, Y, C, and W, with lots as our main unit of measurement. Additionally to this, we had a cost distribution per item, which each item being having its corresponding price and its measurements. This table includes the four different rack types, their price and measurements, some individual cost items such as forklifts, inventory, sprinkler systems, and their prices, and physical spaces and how much they would cost to implement in the warehouse. Finally, we have the materials table, which contains 24 materials, each one having its own row with each column representing a different value to take into consideration. Firstly, we have the materials column, which demarks and classifies the different materials. Next to it, we have the pounds per pallet, which is how many pounds of that material can fit on the pallet, not by weight but by size. Following this, we have the XYCW classification. These are how many units of the material are necessary to create that product. Right next to it, we have the cost per pound of the material, and finally, whether it is flammable or not. Starting the process to get all this data and get to the warehouse layout, we have the first table, which is the total amount of pounds for per demand satisfaction. We took each of the product material requirements in pounds and multiplied them by their respective volumes in lots to find the total amount of pounds necessary of each material to satisfy the demand presented for each product. Multiplying that same value by the cost pound gives us the total value of the materials, and adding them along gives us the total value of all the materials necessary to create every product that will satisfy demands. Next to the total cost, we present the cumulative percentage of total cost of each of the products, which adds up to that 100%. Next to it, we have the table that presents pallets per year, average pallets at one time, and average inventory. The number of total pallets per year represents the number of pallets that the materials need per year to accommodate the goods. This number is found by dividing the total amount of pounds of the material with the pounds of the pallet can hold. From this number, we can find the average amount of pallets there will be in the warehouse at one time by dividing the total pallets by the rotations per year corresponding to their ABC classification, where A gets rotated 8 times, B gets rotated 5 times, and C gets rotated 3 times. Next to that, we have the ABC classification itself. For the materials already sorted from A to C, the average inventory follows that same logic as the average pallets at one time, only that it divides the total cost of materials instead of the pallets per year. Here we start with the necessary data for the warehouse modeling. In this table, we can begin to find the data to model our warehouse. With the average pallets at one time value, we can find how many racks we will need for the warehouse and which type. To find the number of driving racks necessary, we use Excel's floor function, which rounds the number down to the nearest unit of significance, which we marked as 40 for the driving racks and 8 for the conventional racks. This expression gives us the number of pallets that we will need in those driving racks, and then dividing it by 40 will give us the number of driving racks necessary to accommodate that pallet load. The remainder of this number will be the pallets that are fit into the conventional racks, in which we do the same process to find the number of conventional racks necessary to accommodate that pallet load. So using the amount of D racks and C racks necessary, we can calculate that total cost of the racks in the warehouse. For A class and B class items, we choose the 2D conventional rack for easier storage and movement of goods since they will have a higher traffic volume and require more ease of access. For C class items, we choose the 4 high drive-in to maximize the number of pallets we can hold in each rack and to be able to have space for the floor for our higher volume items. The cost is calculated by multiplying the square footage allocated to each ABC class with the cost per square foot.
So here, going off the presentation from my partner, we have the necessary square footage and all the data that we use to analyze the costs of the warehouse and all the racks and the pallets that will be inside of it. So we have two different tables, one for the flammable racks and one for the non-flammable racks, and both of them include what the average pallets that are going to be in each one of the for each one of the materials, how many pallets of those are going to be the drive-in racks and the conventional racks and the floor square footage necessary to have these racks in the warehouse, as well as the square footage of the racks themselves, so that we can have a little bit of a mathematical basis as to how much we can store within them. We also included the costs for the ceiling sprinklers and for the rack sprinklers. Um, Only the flammable racks will have the rack sprinklers, as they are very, very expensive, but also they are the ones that are required to have them, not only for legality purposes, but also just to keep a more safe environment, just in case any of the materials catch fire, as they are very flammable. All of the racks, whether they be conventional or drive-in racks, will have 4 levels, so as to maximize the amount of materials that we can store in them. As for the equipment inside the plant, we have estimated that there is around the cost of $27 million for the average inventory cost of all the materials that we want to have within there. And the rack purchase cost, the ceiling sprinkler cost, all those other costs that add up, we have them outlined there on the table. We've included one office space, one restroom, and 2 utility rooms for our employees, so that they are able to keep the workspace functioning and keep the workflow going, as well as having a little bit of space for their personal needs. There's also the demarcation for the prices for square footage of the ceiling sprinklers and the rack sprinkler systems. This is the layout of the warehouse that is designed by myself. We were not able to fit the 229 drive-in racks necessary to fulfill all the material needs, but we were able to put in 115 of them, and as well meet all the other criteria and quota. So the idea would be to construct another one of these warehouses, or at a second plant that would be solely focused on the drive-in racks, so as to make it a more cost efficient, or maybe even divide them evenly between the two, so we can fit in some more other miscellaneous things to keep the plant running. This was designed within the parameters that were provided to us of the 200 and 250, with the 3 entrances and the 4 exits. It is designed so as to be the most efficient and very easy and accessible for all our employees to use and utilize. Um, we have also put in the pallet unloading zone, just to keep it a more, from my own personal experience, just to keep it a little bit more organized, a little bit more steady, and keep the workflow going a little bit better. And we have the keep clear at all times areas, which are where we will be entering and exiting with the materials, just so that things don't get bogged up and there are no bottlenecks, and we can keep this running to the best level that we can. Thank you so much for paying attention and giving us the opportunity to do this project. I really did enjoy it, and I hope to be doing more of this in my professional career in the years to come. Thank you, and have a